So as you know, it's 9.8. We're doing something called rationalizing the denominator. Just as an example from previous days, the square root of 12. There's no apparent square root right away, but you can break the 12 up. 12 is, if I factor it, is 4 times 3 or 2 times 2 times 3. And when you have a pair of something on the inside, they'll come out to the outside. So two 2's will come out as a single 2. There'll be a 3 left over on the inside. So it's a 2 times the square root of 3. Or if you want to think of it, this is 4, the square root of 4 is 2, and the 3 is left over. So today we'll deal with fractions, and there are two basic rules. Rule number 1. Let's say I give you the square root of 12 over 16. The square root of a fraction. Looks scary, but if you have a square root of a fraction, what you're allowed to do is break this up into two square roots. This is the same thing as the square root of the numerator over the square root of the denominator. So if you have the square root of a fraction, this is the same thing as the square root of the top over the square root of the bottom. The square root splits between the numerator and the denominator. And once you've split it, now you can actually evaluate it. This real hard to do conceptually, the square root of a fraction. But now the square root of 12, I just figured that out. That was 2 square root of 3. The square root of 16, this is 4. And here, now that I've got it this way, I can simplify. Ignore the square root for now. 2 over 4, that fraction. That simplifies. 2 over 4 simplifies to 1 over 2. And then the square root of 3 is still hanging out on the top. And this, you really don't need the 1. So it's the square root of 3 over 2. So this rule number 1 says if you have the square root of a fraction, you can break it up into two pieces. Square root of the numerator, square root of the denominator. Now, with fractions comes an additional rule to this. Let's call it rule number 2. Rule number 2, you're not allowed to have a square root in the denominator. So rule number 2 says you cannot no square roots in the denominator. You're not allowed to leave a square root on the bottom. In my example here, the square root of 16, the square root of 16 is 4. So this square root kind of went away. But sometimes it doesn't. You're not allowed to leave a square root on the bottom. So that's rule number 2. To solve this problem, to solve the problem of square roots in the denominator, what you're going to do is something called rationalize the denominator. Sounds complicated, but this is just fancy talk for getting rid of the square root. So you're not allowed to leave a square root in the denominator. If you do have one, you have to rationalize the denominator, which in normal word means remove the square root from the denominator. Alright, so what do I mean when we say remove the square root from the denominator? So as an example, I'll give you 2 over the square root of 3. Can't simplify it anymore. 2 over, there's nothing I can do with the 2 and there's nothing below it. The square root of 3 I can't simplify because there's no way to break up 3, make a difference. So what I want to do is, it's already been simplified, but it's breaking that second rule of it has a square root in the denominator. I don't want it there. So what I'm going to use is some, I don't want to say trickery. We're going to get rid of it. To cancel out a square root, or better yet, think of this. When you mess around with fractions, when you simplifying or finding common denominators, basically you're multiplying by 1 or dividing by 1. So this fraction I can multiply or divide by 1. I just have to write that 1 in such a way that it cancels out the square root. So I'm going to cheat here. I'm going to tell you I'm going to times. And to cancel out the square root of 3 on bottom, what I'm going to do is I'm going to times it by another square root of 3. What I'm going to get is the square root of 3 times the square root of 3 is the square root of 9, which is just 3. Basically, you could think of it as there's 2 3's in the square root, so you can pull it out, or the square roots will cancel each other out, leaving just the 3. But the square root of 3 times the square root of 3 makes the square root of 9, which is just 3. I'm multiplying by this square root that I see under here. Now you just can't multiply a fraction by the square root of 3 on bottom. You have to multiply it by 1. So what I do is I'm going to multiply the top and the bottom by square root of 3. Square root of 3 over square root of 3, this whole thing is just 1. So it's okay to do. I can multiply anything by just 1. I wrote it in such a way that will help me simplify. On the top, 2 times the square root of 3, I can't combine those, so I just leave it. And here I simplified the square root of 9 to 3. The top is still going to stay the same, 2 square roots of 3. Can I simplify 2 over 3? No. So that's it. I'm done. 2 over the square root of 3, I rationalize the denominator. I multiply it by the square root of 3 over square root of 3. And I get 2 square root of 3 over 3. This has now been written so that there is no square root in the denominator. Let's try again. So what if I give you 8 over the square root of 8? Here, it's easiest to simplify a fraction first before you start trying to rationalize and get rid of the square root. On the bottom, the square root of 8. I can simplify that because 8 is 2 times 2 times 2. Pair of 2's come out. 1, 2 stays inside. The square root of 8 simplifies to 2 square root of 2. Now I'm looking at the whole fraction. I just looked at the square root first. Now I look at the fraction. 8 over 2. 8 over 2, the fraction, simplifies to 4 over 1. I simplified 8 over 2 to 4 over 1. Now I can't simplify the numbers. There's no way to break up square root of 2. Now I'm going to rationalize it. I don't like the square root of 2 down here, so I'm going to multiply by the square root of 2. Top and bottom. What that's going to do, the square root of 2 times the square root of 2. Square root of 2 times square root of 2 is the square root of 4, or just 2. On the top, there's a 4 and a square root of 2. Square root of 2 times square root of 2 is square root of 4, which makes 2. 4 times the square root of 2. You can't combine stuff that's a normal number with stuff inside a square root. So you get the normal number, stuff inside the square root. Lastly, I notice again, I could simplify this again. 4 over 2. Doesn't it become 2 over 1? Or just 2? And then there's that square root of 2. My final answer. Now here I simplified first, and then I rationalized by getting rid of the square root of 2, and then I simplified some more. You don't have to simplify first and then rationalize. You could have rationalized in the very beginning, and I'll do that on this last example. 2x over the square root of x to the third. Let's say I didn't figure out I could simplify that. Okay, I want to get rid of the square root right away. So I'm going to multiply by the square root of x to the 3 over square root of x to the 3. On the top, you get 2x square root of x to the 3. On the bottom, x to the 3 times x to the 3 in the square root comes out as an x to the third power. Right. I can simplify right now. X will cancel out with one of the x's down here, making that x to the 2. So let me rewrite that. The x that was here cancels out with one of the 3 on the bottom, leaving 2 on the bottom. Now I can simplify this more because the square root of x to the 3. This is the square root of x times x times x. A pair of x's can come outside. So that's this x here, leaving 1 on the inside. The 2, this x was one of the pairs inside of the square root, came outside, 1 left over. And this is all over x squared. Lastly, this x can cancel out with 1 down below. So I have 2 square root of x over x. So you can rationalize right away, but it's not as nice. It's a little more obvious if I simplify first. The square root of x to the 3 we already figured out was x square root of x. We figured that out up over here. Right here, the x's will cancel each other out. So I have 2 over the square root of x. Now to rationalize, I'm going to times by the square root of x. When you rationalize, you times by whatever square root you see in the denominator. Square root of x times square root of x is x. 2 times the square root of x is 2 square root of x. Same answer, but I simplified first. In general, simplify before you try to rationalize. Saves us a couple steps.